Good evening, bachcho. Good evening, everyone. I hope we are live. Everybody, please be active on the chat box and let me know. Am I clearly audible and visible to everyone or not? My voice is crystal clear. Yes, we are live. Good evening, good evening, good evening, bachcho. Chaliye. So let's begin. And today we are here to discuss another chapter, gear train. Yesterday we talked about chapter gear. What is gear? How does it look? How does teeth look? What are the different terms which we are going to use inside the gears? We have talked everything. Now sometimes merely a pair is not enough, है ना? Yesterday we have seen that we are going to use some smaller gear called as pinion and a bigger gear which is called as gear. So pinion and gear arrangement sometimes is used, but always having only two gears is it not? It is not sufficient. Sometimes we require multiple gears, more than two gears, and whenever we are using more than two gears, that is called as gear train. Now, first of all, let us try to understand why we even need more than two gears. What is the gear train? Listen carefully. More than two gears in use, if we are having more than two gears in use, that is called as gear train. What is the need? Why we are looking for multiple gears? There are two major aspects for this, है ना? So first thing, sir, suppose if I am using only two gears, what I can achieve? You are suppose using only one smaller gear and one big size gear. Okay. This is pinion, its radius is small r. This is gear, capital R. It is rotating with some angular speed of the pinion, and this is rotating with some angular speed of the gear, omega g. Both the gears are having same module. This is common sense wali baat. Yesterday we have seen meshing gears must have same module, and this smaller gear is having a small number of teeth, and it is having capital T teeth. What is the ratio? What is the relation between these speeds of these gears? Sir, I can write omega p by omega g will be reciprocal of the teeth or reciprocal of the radius. You can write this as capital T by small t, or you can also write this as capital R by small r. Pinion ka speed, so pinion ke teeth you have written here. Gear ka speed you have written teeth of the gear here, this side. So speed ratio is going to depend on the number of teeth ka ratio, or you can also say radius ka ratio. Radius ka ratio means ratio of the size. Now imagine if I want a gear ratio of 2. What is the meaning of gear ratio 2? Sir, this is my driver. Suppose this is my driver and this is my driven body. Here I have given my input, I have connected motor, and its motion I am collecting as my output, and it is rotating with some speed 100 rpm se rotate kar raha hai. This is rotating with 100 rpm. So if I want to reduce speed to the half, 100 rpm se I want to have 50, so half reduction will be there if size mein difference is of the double. This size is smaller, this is of the double size. If its radius is 10 centimeter, so its radius must be 20 centimeter. So by simply using these two bodies, I can use very easily, I can get gear ratio, or I can say velocity ratio. Velocity ratio, how do we define? Sir, velocity ratio is defined as angular speed of the driver divided by angular speed of the driven body. So this is my driver. So angular speed of the driver upon angular speed of the driven body, this depends on number of teeth or size. Size में double का difference. If we are having double difference, then velocity ratio will be 2. If I want velocity ratio 3, 4, 5, so size में differences will be of 3 times, 4 times, 5 times. Imagine 3 times, 4 times, 5 times is still okay, है ना? कि one gear is smaller, other gear is, its radius is 10 centimeter, other gear का radius will be 5 times, it is 10 centimeter, so this is 50 centimeter. Can you feel size में difference of the gears will be of this order? If you are talking about velocity ratio of 5, you will be having this size difference. One gear is so small, other gear is so big. And when the size difference is increasing, so inertia is also quite different. Can you imagine? This gear is having small teeth. Here, small size teeth. Here also we are having small size teeth. Do you understand that, sir? If size ka difference is quite high, so this bigger gear will become very heavy as compared to this gear. So small teeth, are they able to rotate this? Because of the inertia property, it will be very difficult for my smaller gear to rotate this. Theoretically you can say, okay sir, ठीक है, if size ka difference is 5 times, 6 times, so its speed is 6 times more than this one. Theoretically it is okay, but practically I have some gears made up of steel. So this smaller gear will be very lightweight and the bigger gear will be very heavy. So up to velocity ratios 2, 3, 4, 5 can be easily achieved, but sometimes practically we require velocity ratios of the order of 10:1, 20:1, 100:1. Even this is required. So exceptionally high velocity ratio we are calling it. To get the exceptionally high velocity ratios, I must go for multiple gears. I simply cannot use two bodies. Why? Sir, if you want to have 20:1 velocity ratio, that means a smaller gear is smaller in size and the bigger gear is 20 times bigger. Imagine kariye, only 5 times difference of the size was there, and you can see, sir, one is very small, other is quite big. But if I say 20:1, 50:1, then the differences will be, unimaginable. ठीक, clear है बात? So my main technical aim is to get exceptionally high velocity ratio. Exceptionally high velocity ratio. What is the meaning of exceptionally high velocity ratio? Of the order of 10:1, 20:1, 50:1. This is the exceptionally high velocity ratio. 100:1. These kind of velocity ratios only a pair cannot give. Definitely it cannot give. Using a pair, what you can get? Sir, using simply a pair. Using a pair, how much I can get? Only of the order of 2:1 up to 4:1, 5:1. This kind of things I can get very easily. But beyond this, it becomes higher velocity ratios. 10:1 ko I am saying exceptionally higher velocity ratios. Sometimes we have this requirement. Sometimes we need to connect large center distance. To connect large center distance. Now try to understand this. If center distance is large, I'm not saying that it is very, very large where belt drive is needed. I'm not talking about that huge distance. But imagine kariye, sir, I have to connect this shaft to this shaft. These are the two shafts, axis of the rotations. Shaft is perpendicular to the board towards you. You have two choices. First choice is you can connect one gear like this, and you can have other gear which looks like this. These two big size gears you have shown, है ना? Let me make it even bigger. अरे भाई साहब, let me make it even bigger. These are the two gears. Both are big, है ना? So it is not कि sir this is very small. How it can, make it rotate? Both are the similarly big, but in whatever machine you have used these two gears, can you imagine? In the weight, the mass of the machine is going to increase very badly. If you simply want to transfer motion from this shaft to this shaft, either you can have this big gears ka pair, or you can use smaller size gears, multiple gears. Sir, I have one gear, it is driving another gear, it is rotating, now it is driving some other gear, it is driving some other body. We can have these kind of situations also, है ना? And finally we have this kind of situations we can have. Tell me in the chat box, are you able to understand? If I am using multiple smaller gears, inertia of the entire machine, weight of entire machine is going to reduce drastically. Instead of using these big gears, I will prefer multiple gears of smaller size. So to connect large center distance also, we can think of using gear train. This is my large center distance. I hope this is clear to you. So these are my two aims: to get exceptionally high velocity ratio or to connect large center distances. I can think about the gears, think about the gear train. Now, what are the types of the gear train which we can use? Acha, before we enter into the types of gear train, let me tell you some terms which I am going to use here. The very first of all, in gear train we will be having multiple gears, है ना? If I am using only pair, so one is driver, another is driven body. Simple. But here in this case, I'm having so many gears. One gear I am saying that this is your main driver where I am giving input, है ना? Types of gears we are going to have. First one, main driver, where you have given the input you have given here. The last gear from where you have collected the output, whose motion you are collecting as output, it is called as main driven body. Here I am collecting output from, and all other gears which are in between, they will be called as intermediate gear. Intermediate gears. Acha, at what speed these intermediate gears are rotating, I am not interested in. I am just interested that input mein what speed I have given and output mein what speed I have got. I am only interested in this. Intermediate gears, I am not interested in their speeds. And how my gear train is behaving, how it is working, to check the performance, I have defined a parameter which is called as, again, gear train mein velocity ratio. How it is defined? It is defined as the ratio of angular speed of the main driver. Driver ko I am writing main DVR, matlab driver. Angular speed of the main driven body. Ratio of main driver to the main driven body ki velocities. This is called as velocity ratio. So how good, how effective is my gear train? I will check that with this parameter, velocity ratio. Velocity ratio, or you can also call it as speed ratio. Speed ratio or velocity ratio. this I want to be very very high. I want, sir, main driver ka speed is 10 and output ka speed is 1 rpm, 10:1, है ना, 50:1. I want this ratio to be high. Clear है ये बात? No. Bigger gear is rotating at slower speed. Smaller gear is rotating at higher speed. Bigger gear is rotating at slower speed. ठीक है, ऑब्वियस सी बात है. Smaller gear always rotate at higher speed. Bigger gear will be rotating at slower speed. Let me write this. This is fast. This is slow. Smaller gear rotates faster and this big gear rotates at slower speed. Common sense wali baat. Now, the very first thing which comes to my mind is, sir, when I think of gear train, multiple gears, so the very first thing which comes to my mind is that any one gear, acha, all the gears ko I am representing with their pitch circles, frictional disc jaisa I am representing, although there will be some teeth are engaging, but yesterday I have told you that I can represent gears with their respective pitch circles. So one gear is this, from front you are seeing, so gear will be looking like this circle, disc jaisa dikhai padega. So this is the one gear. It is driving, this is my driver, main driver, it is driving another gear. This gear is driving another body, another gear. This body is driving another gear, and this finally it is driving another gear, है ना? And I'm calling all these gears are rotating about their fixed axis. यानी कि situation is something like this. The very first thing which comes to my mind, okay sir, so you are giving input here, output you are collecting from here, and this input and output shaft you have connected with the help of some intermediate gears. These are my intermediate gears. Intermediate gears. Careful. This is the simplest thought I can have in my mind, and this is called as a simple gear train. Why simple gear train? Arey sir, you were talking about gear train. So apart from input and output shaft, there must be so many gears in between. Every shaft which is in between is having one gear, one active gear. This is simple gear train. Simple gear train. Acha, let me give it some name. Sir, this is my gear number 1, gear number 2, gear 3, gear 4 and gear 5. I have shown 5 gears. You may have 15, 20, 50 gears. So many gears you can have. What you are interested in? Sir, I am interested in what is the ratio of angular velocity of gear 1 to the omega 5. Omega 1 to omega 5 I am interested in. Omega 1 divided by omega 5. How much it is? I want to know this. And I have connected in between these few gears in a hope that they will be giving me a brilliant velocity ratio. Acha, one can see very easily that gear 1 is meshing with gear 2. So meshing gears must have same module. यानी कि M1 must be same as M2. Obvious सी बात है. M1 must be same as M2. And this 2 is meshing with 3. So M2 and M3 they must also be same. Sir, 2 and 3 they must be having same module. M2, M3 it must be same. 3 is also meshing with 4. So M3 must be same as M4 and 4 is meshing with 5. So M4 must be same as M5. यानी कि all the gears which you are using here, they must have same modules. All gears must have same module, and this is very big condition, beta. If I say go to the market and find a pair, which can give me velocity ratio 2, यानी कि whatever is the size here, other gear is having double size. Velocity ratio 3, whatever is the size of this gear, other gear ka size should be 3 times, है ना? 10 teeth, 30 teeth, 10 teeth, 20 teeth, velocity ratio 2, velocity ratio 3. So go to the market and find out these gears. Finding a pair of of same module is very easy. You will ask to the shopkeeper, bhaiya just give me 10 teeth 20 teeth ka pair, same module, he will give very easily. But if you'll go to the market in a hope that give me 5 gears, every gear must have same module, and this gear must have T1 teeth, this gear T2 teeth, this gear is having T3, T4 and T5 teeth. So number of teeth you have told me, number of teeth you have told me that T1, T2, T3, T4, T5, these many teeth, and every gear is having same module. Finding these many gears of same module is very difficult task. You will have to find out, you will have to search for 3-4 shops, or maybe entire area you have to scan. Then you will be able to find out, maybe you will be able to find out these desired number of teeth, same module wala gears. Luckily, if you can manage, you have purchased these gears in a hope that I'm going to get some magical velocity ratio. What is the velocity ratio you are going to get? Sir, how can I write equation? You can write equation like this: gear 1 and gear 2. For meshing gears, I can say gear 1 is driving gear 2. So between this 1 and 2, I can write omega 1 by omega 2. Omega 1 by omega 2 is equal to reciprocal of the teeth, T2 by T1. Sir, between 1 and 2, I can write. Sir, 2 and 3, they are also meshing. So for 2 and 3, I can write. Kya? Omega 2, whatever speed say it is rotating, omega 2 speed say. So omega 2 by omega 3, it is T3 by T2. Reciprocal of the teeth once again. Now 3 is driving 4. So omega 3 by omega 4. Can I write T4 by T3? And now 4 is driving 5. So 4 and 5 are meshing. So between these 4 and 5, I can write meshing gears ke liye I can write this equation omega 1 by omega 2 T2 by T1. Reciprocal of the teeth wala logic I can use for the meshing gears. Now 4 is driving 5. So omega 4 by omega 5 is T5 by T4. Sir, individual pair ke liye what is the velocity ratio I have got? I am not interested in this. In between intermediate gears ka what is the velocity? I am not interested. I am interested only in what is the value of omega 1 by omega 5. How can I find out this? Sir, do one thing. You have this relation, this relation. There are 4 relations. Equation 1, equation 2, 3, 4. Just multiply all these. Equation 1, equation 2, you are calling it as 3, you are calling it as 4. Multiply all these equations. Equation 1 into 2 into 3 into 4 into 5. What you will get here? Sir, or by omega 1 by omega 2 into omega 2 by 3, omega 2 by omega 3 into 3 by 4 and 4 by 5, omega 3 by omega 4 and omega 4 by omega 5. So we are having these 4 equations. What it will be equal to? It will be equal to T2 by T1, T3 by T2 and so on. Write it here. So omega 1 by omega 2, it will be T2 by T1. 2 by 3, so T3 by T2. 3 by 4, so T4 by T3. 4 by 5, so T5 by T4. So this is how you have written. I think few things are getting cancelled. Sir, omega 2 gets cancelled here. Omega 3 gets cancelled, omega 4 gets cancelled. So you are left with only omega 1 by omega 5. This is something you wanted. Yahi to hai. This is your velocity ratio. Omega 1 by omega 5. And it is coming out to be this product of teeth. But wait a minute. I think there are few more things which are getting cancelled. Are bhaiya T2 gets cancelled, T3 gets cancelled. Every intermediate teeth, gear 2, 3, 4, all intermediate teeth are getting cancelled. Finally, I am left with only T5 by T1. Sir, omega 1 by omega 5 is only depending on teeth on 5 and teeth on gear number 1. Intermediate gears ke teeth are not even participating in the velocity ratio. Sir, I scanned all the shops of my area. Then I found these same module ka different number of teeth ka gears. And these are not even participating in the velocity ratio. That's why these are called as idler gear. Idler. They are just acting as a transmitting body. They are not contributing any good thing to the velocity ratio. It was your intention. My main intention was to get some exceptionally good, exceptionally high velocity ratio. That's why I have used these gears, and they are not even participating. They have big condition. If you want to use us, everyone must have same module. Even after this big condition, you are not contributing. Idler gear. This simple gear train is called as the worst gear train. Not used at all. By purpose of using gear train was to get some good velocity ratio. You are not getting any good velocity ratio. Clear hai baat? Sir, is there any use of this? Yes. Once you have made this, you can use this gear train for some purpose. Although this is not a good velocity, good gear train, but you can utilize in some cases. Like first case, sir, at least you can connect large center distance. To connect large center distance, you can use this. Logical baat. Second thing, you can also use this to play with the direction of output and input gears. What does it mean? Logic se dekhiye. Sir, if my gear 1 is rotating with in clockwise direction, this is clockwise, so it will rotate anti-clockwise. External meshing hai, anti-clockwise. This is anti-clockwise, so it will be clockwise. If it is clockwise, so it will be anti-clockwise. So it will be again clockwise. Getting a point? Sir, this is clockwise, output is also moving with clockwise direction. How? In between we have used 3 intermediate gears, 3 idlers. So this is clockwise, same direction mein. What if I use one more gear here? So how many idlers? 1, 2, 3, 4 idlers. Now what will be the speed? Clockwise, anti-clockwise, clockwise, anti-clockwise. This is clockwise and it becomes anti-clockwise. So I cannot change the magnitude of the speed, but direction ke sath I can play. Direction I can reverse. है ना? This thing otherwise you cannot get. So if number of idler is odd number, like if we are having 3 idlers, so direction of input output is same. Direction of input and output is the same. On the other hand, if we are using even number, so for direction will be opposite. This thing you can do. It was otherwise not possible. You cannot simply say, sir, omega 1 by omega 5 is T5 by T1. It looks like that I have only used a gear 1 and gear 5. Only gear 1 and gear 5. You cannot simply say this. This is my gear number 1, gear number 5. If you will correct only these 2 gears, so omega 1 by omega 5 will be no doubt T5 by T1. But if one is clockwise, so other have to be anti-clockwise. But in gear train, simple gear train, you can even change the direction of gear 5. You can make it rotate in clockwise direction. How? By changing, by playing with the number of idlers. Even numbers, odd numbers, you can play with the direction. Clear hai baat? So this is some good feature of this simple gear train. Now, simple gear train, I hope everybody has got it. Not of much use. Then comes into picture compound gear train. Compound gear train. And believe me, bete, this chapter gear train is very, very scoring in nature. Examination mein whatever questions they will be asking, it will be very easy to solve it. Compound gear train. Acha, let me tell you another shortcut method. Even to solve this one, for the first time I have shown you how I write equations. Multiply and then I get velocity ratio. But next time onward, I will not write all this. I will directly write it. How I am writing it? Let me just. Suppose I have this gear train and I have to write equation between 1 and 5. So omega 1 by omega 5. Try to understand, try to feel, because now whatever I am saying, I will not be able to write this. Between 1 and 5, you have to write the equation. कैसे लिखेंगे? How this power is flowing, sir? 1 is driving 2, 2 is driving 3, 3 is driving 4, 4 is driving 5. How this power is flowing? Between 1 and 5, I am writing the equation. So 1 is driving 2, so T2 by T1. Now 2 is rotating, 2 is driving 3, so T3 by T2. Now 3 is rotating, 3 is driving 4, so T4 by T3. Now 4 is rotating, 4 is driving 5, T5 by T4. That's it. Simple सी बात. You are writing between 1 and 5. So 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. 1 is driving 2, T2 by T1, 2 is driving 3, T3 by T2, 3 is driving 4, T4 by T3, 4 is driving 5, T5 by T4. You have written like this. Simple सी बात. Few things will be cancelled, you can solve it. है ना? I am getting the same answer. Sir, T2, T3, T4 gets cancelled. T5 by T1. Same answer. Same result. Now, coming to the compound gear train. How does it look? Compound gear train, how does it look? Careful. Sir, what is the meaning of compound gear train? If in my gear train, earlier whatever gear train we have studied, here all the intermediate shafts were having only one gear, one active gear. Input shaft, output shaft, intermediate mein each shaft was having one gear. Now, if intermediate shaft has more than one gear, more than one active gear, it is called as compound gear train. Entire train becomes compound gear train. Careful. How does it look? It looks something like this. Sir, I have, this is my input gear, gear number 1. It is driving some gear, gear number 2. Now gear 2 is rotating on some shaft. On the same shaft at the back side, I am having another gear. Same color say I have made it, and let me make it this dashed so that it is giving you a feeling that this yellow color ka gear is outside and this bigger gear of white color is backside. है ना? So this is my gear number 1. 1 is driving 2. 2 is rotating on the same shaft. I am having gear 3. It is also rotating with the same angular speed. 2 and 3 are compound. 2 and 3 compound. This is called as compound gear. Whenever on the same shaft I am having 2 gears, it is called as compound gears. Now 3 is driving another body. This gear number 4. 4 rotates, and on the same shaft where 4 is, on the same shaft I am having another gear. Looks like this. Let me make it again dotted. 4 and this is gear number 5. 4 and 5 they are compound. 4 and 5, this is also compound. Now 5 is driving, suppose, some other gear, gear number 6, and gear 6 ka motion ko I am taking as output. So I have given input on gear number 1, output I am collecting from gear number 6. Clear hai baat? Sir, apart from input output, whatever we have, it is called as intermediate gears. Now intermediate, this shaft is also having compound gears, this shaft is also having compound gears. Bete, even if any one shaft was only having compound gears, here only one gear was there. So even only one shaft is having compound gears, this train will be called as compound gear train. Keep this in mind. In this case, which I have shown here, this shaft is having compound gears, this shaft is also having compound gears. But even only if one shaft is having compound gears, then also this entire train will be called as compound gear train, because compound nature has been introduced. First thing, you must appreciate the beauty that, sir, here in this case, gear 1 and 2, they are meshing, so M1, M2 must be same. 2 is not engaging with anyone. 2 is rotating, 3 is rotating automatically because they are in the same shaft. Now 3 is driving 4. So M3, M4 must be same. Engaging gear, meshing gears must be having same module. M3, M4 must be same. Now 4 has rotated, 5 automatically rotates, 5 is driving 6. So M5 is equal to M6. Yani ki very big condition which you are having earlier, that M1, M2, M3, M4, M5, M6, everybody should be same. Every gear must have same module. That big constraint have been released. Now only meshing gears, M1, M2 must be same, M2, M3, M4 must be same, M5, M6 must be same. This all together they are same, it is not compulsion. Only pairs of meshing gears must be same. So very big relief. Earlier all the gears were having same module. Now it is not a compulsion. And how can I write the equation? Sir, for the velocity ratio, let's check whether these gears, compound gears, are participating or not. How can I write? Gear 1, same shortcut say I will write this equation. 1 is driving 2. How between 1 and 6 I have to write equation. How the power is flowing? Power is flowing from 1 is driving 2. Now 2 rotates. 2 is not driving 3. 2 rotates, 3 automatically rotates. So 1 is driving 2. Now from 2 power has moved to 3. 3 is driving 4. 4 has rotated. 5 automatically rotated. And then we are having 6. 5 is driving 6. How I am writing the equation? Omega 1 by omega 6. Between 1 and 6 I am writing the equation. What it will be? 1 is driving 2. So T2 by T1. 2 is rotating. 3 is automatically rotating. It is not meshing. 2 is rotating. 3 is automatically rotating. Now 3 is meshing with 4. T4 by T3. T4 by T3. Now 4 is rotating. 5 automatically rotates. 5 is driving 6. So T6 by T5. And bete, no teeth is getting cancelled. If you will see here, sir, input teeth T1 is there, output teeth T6 is there, and even all intermediate gears T2 and T3 are there. T4 and T5 are also participating in the velocity ratio. So all the intermediate gears, input output, they were all already participating in the velocity ratio. Now here in this case, even all the intermediate compound gears are participating. This time they are not called as idler. They are compound gears. Every compound gear is going to participate. Clear hai ye baat? Tell me in the chats if anyone is having any problem. Lectures for gate aerospace also please. ठीक है, ठीक है, ठीक है. I will communicate your request to the team. Every compound gear, in between whatever compound gears we were having, every gears is participating in the velocity ratio का formula. This is something which is useful. Sir, ultimately velocity ratio I wanted to be high and all intermediate gears are contributing here. No need to remember this formula. I am not giving you formula. I am just telling you how to write the equation. For example, if sometimes you are having a situation where, careful, this is my gear 1, 1 is driving gear number 2, 2 is rotating, 2 is driving gear number 3, 2 is driving gear number 3. 3 is compound with another gear, gear number 4. 4 is driving some gear 5, and this 5 is driving gear number 6. Like this, we are having situation. Careful, careful, careful. Sir, gear number 1, gear number 2, 2 is driving 3, 3 rotates, 4 automatically rotates, 3 and 4, they are compound. 4 is driving 5, 5 is driving 6. Input I have given here on the gear number 1, and output I am collecting from here. Apart from input, output, whatever we have, they are called as intermediate gears. Intermediate gears. What are the compound gears? Only these are the compound gears. 3 and 4 are the compound gears. Sir, what about this? What about 5 and 2? They are not compound gears. On their shaft, there is only one gear. On this shaft, there is only one gear. So, in this, gear train, can we call this as compound gear train? Yes, this is compound gear train. Why? Even if there is one shaft having more than one gears, it will be called as compound gear train. What gears are going to participate in the velocity ratio formula? Sir, input will be there, output will be there, and intermediate shafts, intermediate may whatever compound gears are there, they will be participating in the velocity ratio formula. This will not be there, this will not be there. So gear 2 and 5, they are called as idler. What are the idler gears? Sir, I will say gear number 2 and gear number 5, they are the idlers. Their teeth will not be seen in the picture. If you can understand this, you can directly tell, or you can write the equation. Sir, omega 1 by omega 6, if I'll write 1 is driving 2, so T2 by T1. 2 is driving 3, T3 by T2. 3 is rotating, 4 automatically rotates. 4 is driving 5, so T5 by T4. 5 is driving 6, T6 by T5. Few things are getting cancelled, but a 2 gets cancelled, 3, 4, 5, 5 gets cancelled. What we are left with? We are left with only T3 is there, T4 is there, T3, T4 is there, and input gear, output gear, they will certainly be there. All idlers are getting cancelled. Compound gears will be participating in the picture. How many of you can understand this? Gate mein sometimes they ask question ki this gear train is shown. For 1 mark gate mein question will be there ki just tell me how many idlers we are having here. Simply you can count, this is idler, this is also idler. Apart from input shaft, output shaft. Intermediate shaft mein if you are having only one gear, so that will be your idler gear. Clear? It is not tough. Not tough at all. ठीक है? Then compound gear train ही, but some special type. We have reverted gear train. Reverted gear train. What is the nature of this gear train? Sir, by nature this is also compound gear train. It means intermediate shaft mein we are going to have more than one gear. Compound gear train. How does it look? Why we are calling it as reverted gear train? Reverted gear train का मतलब होता है that whatever is the input axis, input gear का axis, same axis के about we are going to have output gear. Let me show this. Suppose we are having, this is the shaft on which I am having one gear, and now for the sake of clarity I am showing you some different view of the gear. Gear from front, if you will see, you can see the circle, but same gear ko side se if you will see, you will see the rectangle part. है ना? So one gear is on this shaft, and this shaft is rotating about this axis. This is the dotted line. I have shown the axis. You are having a gear, one gear on this shaft. I am having, this is my gear number 1. Gear 1 is engaged with another gear. This is another shaft where we are having some gear like this, This gear is on some shaft. On the same shaft, I'm having another gear like this. So one is driving 2, and this gear 3. They are on the same shaft. So I will say that they are the compound gears. Now 3 is engaging with another gear whose shaft is here, and we are having gear 4, which looks like this. This is your gear number 4. This is your gear number 4. So how many of you can see, sir, whatever axis ke about gear 1 is rotating, same axis ke about your gear 4 is rotating. Axis of rotation is same. Axis of rotation is same. If I'll go, whatever view I have shown, in this view it is clearly visible that which gears are on the same shaft and which gear are on different shafts, just coaxial. So reverted का मतलब है input and output gears are coaxial. Clear है बात? To solve this kind of question, again there is nothing new. Just I wanted to show you this picture. Bhaiya, this is a reverted gear train. By nature it is compound, so just like compound we can solve it. If you write the velocity ratio का formula, omega 1 by omega 4, omega 1 by omega 4, 1 is driving 2, so T2 by T1, 2 is rotating, 3 automatically rotates, 3 is driving 4, to T4 by T3. This is how we can write the equation. That's it. If I have all the teeth, I can simply write the equation very well. But sometimes to make this question a little tough, they can miss any one teeth. All teeth they will not give. So missing teeth ko we can find out with the help of some radius ka relation. How? Imagine kariye this gear 1 and 2 they are meshing, so obviously baat hai M1 M2 must be same. Module must be same. 3 is meshing with 4, so M3 must be same as M4. And can you see, whatever is the radius of gear 1, radius of gear 2, pitch circle ka radius, R3 radius, and this is R4 radius. So we are having some relation in the radius. I can see here that this R3 plus R4 is same as R1 plus R2. Can I write? Radius mein some relation is there. R1 plus R2 is R3 plus R4. In your question, some new question will be there. You will be having some different radius ka relation. And radiuses ko in terms of teeth, I can write something. How? Sir, yesterday we talked about module is d by t. Module is d by t. Diameter ko we can write twice of radius r. So radius r, teeth and module mein there is some relation. Can I write? R is equal to mt by 2. Are yes or no beta? From where I can write this? Sir, yesterday's lecture mein we have got a clear idea that d by t is module. So I have written radius, module, teeth, some relation. Can I simply write radius r1 ko I can write m1 t1 by t2, m1 t1 by 2, m1 t1 by 2 plus m2 t2 by 2 will be same as m3 t3 by 2 plus m4 t4 by 2. Sir, m1 m2 is same. Let us suppose this value is m, and m3 m4 ko I am saying as m dash. Let me write this a little bigger. So you have got some radius correlation. Do one thing, m1 m2 is same as m, take it common. So m will be outside, 2 gets cancelled. So you are having m t1 plus t2. m3 m4 is same, m dash, take it common. We are having t3 plus t4. You have got this beautiful relation. So modules m and m dash they have given, t1, t2, t3 they have given, t4 was not given. I can find out what is the value of t4. Clear hai baat? Then, and if all the gears, it is not a compulsion, but if they have said for the sake of simplicity that all the gears are having same module, m is the same as m dash if it is given. So even m and m dash gets cancelled, and I am having t1 plus t2 equal to t3 plus t4. You have got this value, this relation. And how many of you can feel that whatever relation you have got in the teeth is the same as radius का relation. So with the help of this radius wala logic, if some teeth they have missed, you can find out this value. You can calculate missing number of teeth, and once you have all the teeth with you, omega 1 by omega 4 is not a big deal. बताइए. I hope this is clear. Chats may be active and let me know if everyone is comfortable. Is this clear to everyone? ठीक है. Sometimes this radius का relation, teeth का relation, module का relation, even they are not even asking about the velocity ratio. They are simply asking play with the radius, teeth and module. That's it. है ना. Let me show you one question. Like in GATE 2013, already 2 marks where they have asked one question. How that question looks? A compound gear train with gears PQRS is shown in the figure. I hope from the diagram you can see the picture. Gear P is driving Q, Q is compound with R is driving S. Okay, ठीक है. Number of teeth they have already mentioned 20, 40, 15, 20. So let me mention 20 teeth, 40 teeth, 15 teeth, and here also we are having 20 teeth. We are having this number of teeth. These are my gears P, Q, R, S. And from the front view, they have mentioned that Q and R, they are on the same shaft. Where they have mentioned? Sir, they have mentioned Q and R are mounted on the same shaft. Now we have seen, sir, reverted gear train mein we have seen that gears are sometimes coaxial also. Same shaft mein hai. Sir, sometimes gears are coaxial and front view se it is not clear. Side se you have to see whether Q and R, they are on the same shaft or they are just coaxial. So whenever they will give you this diagram, they will mention in the question that whether they are coaxial or they are compound. Unless until they have clearly said that they are compound, you will by yourself you will not be able to make it clear that they are compound or coaxial. In this view, it is not clear. If they have given this kind of view, here it is quite clearly visible that they are compound or coaxial. So here they have clearly mentioned that they are compound gears. Q and R, they are the compound gears. They have also given some relation. The diameter of gear Q is twice of the gear R. क्या कह रहे हैं? Sir, diameter of gear Q is twice of gear R. Diameter of R. Okay. If the module of gear R is 2 mm, module of gear R is 2 mm, the center distance between P and S we have to find out. How do we solve this question? Let me draw the diagram clearly. Sir, we have this gear known as P. This is my gear number P. P is driving Q. Where is the Q? Sir, this is the gear Q. This is gear Q. Q is compound with R. This is the gear R. And R is engaged with S. This is my gear S. Okay? This question they have given. Let me write some name we are having. This is P, Q, R, and this is S. Now it is clear. This kind of diagram they have given. Let me change the color. They are the compound. On the same shaft they are like this. What they are asking? They are asking simple distance between P and S. How can I write this? Even a blind person can see that, sir, if you can find out what is the radius of P, add radius of Q here, add radius of R, add radius of S. All the radiuses if you'll add, you can find this center distance. This center distance they are asking. Alright, yes or no? How we can start solving this question? All the teeth they have already given. Even in some cases they have given the module also. Module of gear R will be same as module of gear S. Can I write? Why? Because they are the meshing gears. They must have same module. So module of gear RS is known, teeth is known. Can I find the radius? Yes. Radius of R kitna ho jayega? Radius of R is mt by 2. mt by 2. What is the module beta? 2 mm. Teeth is how much? How many teeth on R? 15 divided by 2. This is coming out to be 15 mm. This is the radius. Radius of S will be how much? mt by 2. M module of S, teeth of S. Module of S is 2. Teeth on S is how many? 20 divided by 2. It will be 20 mm. So 2 radiuses I have got. R and S ka radius I have got. Q and P, I don't know what is the module. Hai na? But they have given radius, diameter of R is twice of Q. So sorry, diameter of Q is twice of R. So if diameter is twice, radius will also be twice. So radius of Q is twice of radius of R. Can I write this? Radius of R I know 15. So this Q ka radius will be 30 mm. Or yes or no? I have got Q ka radius, S ka radius, R ka radius. And once you know radius of Q, you know teeth they have given. What is the module you can find out? Sir, module hota hai, module of Q is D by T. D by T. Diameter of Q is how much? 30 into 260. Or yes? 2 into 30, which is 60 divided by teeth. How many? 40 teeth we are having. So 60 by 40, kitna? 60 by 40, this will be 3 by 2. 3 by 2 mm, this is the module of Q. And whatever is the module of Q, I know module of Q is equal to module of P. Because they are meshing gears. So module of P, you know. So can you write radius of P will be mt by 2. What is the module? 3 by 2. How many teeth on P we are having? 20 divided by 2. Solve it. 15 mm. So you have got this value also. This radius. So 15 mm, 20 mm, 30 mm, 15 mm. All these radiuses I have got. What will be the center distance, beta? 15 plus 20 plus 30 plus 15. This is coming out to be 80 mm. What is the answer? 80 mm is given as option B, Bombay. Tell me in the chats, comfortable or not? I hope this is clear to everyone. ठीक है? I have another question. Not tough at all. This diagram is visible to everyone. They have simply given a gear train, big gear train. I don't know what to call this. You tell me They are saying that this is my driver body. Its name they have given as 2. It is driving 3. 3 and 4 are compound. 4 is driving 5. 5 is driving 6. So first of all, tell me in the chats, can I call this a compound gear train? Input and output shaft, apart from this intermediate shaft may at least one place may I have compound gears. This is not compound. So can I call this as compound gear train? Yes, we can call it as compound gear train. Even if we are having one one compound shaft, one compound gear, compound gear train I can call it. Question they are saying simple gear train is made up of 5 gears. 1, 2, 3, 4, 5. There are the 5 gears. Number of teeth they have mentioned N2, N3, N4, N5 and N6. Tell me how many, which gear act as idler? Can you tell me answer? What is the idler gear here? I just discussed what gear is acting as idler. Sir, if I write the velocity ratio of formula, input will participate, output will participate. Intermediate shaft may only compound gears will participate. This will not participate. 5. Something you are calling as 5, it is not participating. So can I directly, without writing anything, can I directly say only 5 is your idler? बताइए बेटा. Can I simply say gear 5 is going to be acting as idler? ठीक है. Now, if we have understood what is compound gear train, what is simple gear train, now we can talk about another special thing which is called as epicyclic gear train. How does it look? How does it work? Let's try to understand this. An examination where this is, quite frequently asked. I'm talking about epicyclic gear train. Epicyclic gear train. Epicyclic means the cyclic word represents rotation, and epi means axis. If axis of any gear is rotating, all the times whatever we have studied, simple gear train or compound gear trains, gears were rotating till now about their fixed axis. Even in some cases I have shown it fixed, like here I have shown fixed axis about gears are rotating. Here also gears are rotating about their fixed axis. Even if I haven't shown, they were fixed. But apart from rotation of the gears are rotating. If any of the entire gear train may, if even a single gear is there whose axis is also rotating, about this axis gear is rotating, and this axis is also moving about some another axis, nature epicyclic is introduced, and that entire train will be called as epicyclic gear train. And I don't know how to solve this question. Why I'm saying this? Beta, like if we are having one gear engaging with another gear, both are rotating about their fixed axis. How to solve it? It is very easy for me. This is my gear number 1, this is my gear number 2. Number of teeth T1 and T2. One is rotating with omega 1 speed, it will rotate with omega 2 speed. How can I write the relation between omega 1 omega 2? Sir, I have omega 1 by omega 2 is T2 by T1. I simply know this. And what does this indicate? Omega 1 by omega 2 is T2 by T1. It indicates that if you have made omega 1 as 0, means if you hold this omega 1, if you hold this gear 1, गियर 1 का स्पीड इज 0, तो ओमेगा 2 कैन बी रिटन एज, ओमेगा 2 क्या हो जाएगा सर, ओमेगा 2 विल बी ओमेगा 1 टाइम्स T1 divided by T2. Can I write it like this? So if you have made your omega 1 0, you have holded this, fixed this gear, so omega 2 have to be 0. And this quite common sense wali baat, I can see it, if you hold this gear stationary, other gear will not be able to move, obvious baat hai. On the other hand, let me write, if omega 1 I make it 0, omega 2 have to be 0. Omega 1 is 0, so omega 2 have to be 0. It will be 0 automatically. On the other hand, if I am having one gear, this is my gear number 1, it is engaging with another gear, and the other gear ka axis is not fixed. This gear is rotating about the fixed axis. This gear is rotating about the fixed axis. Other gear ka axis is not fixed. How? I have one arm. This is the arm. Arm ko I have engaged here. Sir, it is having pin joint here. Arm can rotate freely. And arm here, it is carrying another gear. So this gear can rotate and its axis can also have motion like this. So this gear is having actually revolution. Like Earth is moving around the sun. Earth is rotating about its axis, spin, and its axis also moves about the sun. This kind of motion we are having here. Acha, number of teeth on gear 1 and gear 2 we have T1 and T2. Here I cannot use omega 1 by omega 2 as T2 by T1. Why? Because if you are writing this equation omega 1 by omega 2 T2 by T1, it means if omega 1 is 0, omega 2 have to be 0. But even in this case, even if I hold this gear 1, make it stationary, can you see gear 2 can still have rotation because of the presence of this arm. So I cannot solve this question. I don't know how to solve this question because only one equation I had. But this equation cannot be used here. It is not valid here. Why? Because arm is rotating. If you fix this arm is fixed, it means this end is now automatically fixed. Now I can use omega 1 by omega 2 is T2 by T1. I can use now. Hai na? So let me write, even if omega 1 is 0, omega 2 non-zero I am going to get. Even if omega 1 is 0, omega 2, it can be some non-zero value because of the rotation of the arm. And I hope everybody can feel this. Okay? Sir, because of the rotation of arm, I am not able to solve this question. Forget about the direction. Direction will be so much confusing. All other gear trains may we can simply say this is rotating clockwise, so it will rotate anti-clockwise. Here, I will not be able to claim anything about the speed, about the direction. I will not be able to see, sir, this is rotating clockwise, so it will rotate anti-clockwise. I cannot say this. Why? Because arm ka rotation is making everything so tough. So now, for the sake of direction calculation, I must depend on the mathematics. How mathematically I can write? Sir, if we are having external gearing like this, in case we are having in external gearing, so I will be using omega 1 by omega 2 equal to T2 by T1 negative direction के साथ. What does it negative sign indicate? Negative indicates कि whatever is omega 1 का direction, omega 2 is having opposite direction. If we are having internal gearing, sometimes gear 1 is internally meshing with gear 2. So whatever is the direction of gear 1, same direction, so omega 2 will be having. So I'll be using positive sign in that case. So minus plus, now I have to use mandatory. It is not a choice, it is mandatory. One student said, sir, what is the problem? Why you are not able to use? Why you are not able to use omega 1 by omega 2 equal to T2 by T1? Sir, because this arm is there. Careful, careful, careful. A student said that, sir, arm is rotating, but what if the student, what if I sit on this arm? I'm sitting on this arm. I'm also rotating. I'm also moving with arm. And if I'm sitting inside the bus is moving. I'm also part of the bus. For me, bus is at rest. With respect to me, bus is at rest. Relative motion of the bus is 0. Relative motion of the bus is 0. But when I look outside, so I will find that tree is moving in backward direction. That means if I am sitting on the bus, so bus is stationary for me, but all other things ka velocity, now I am not seeing the absolute velocity. Now I am seeing the relative motions. Tree, I can feel that tree is going backward direction mein. So this person said happily, sir, I am sitting on this arm. For me, this arm is at rest because arm was moving. You were not able to write omega 1 by omega 2, T2 by T1. I am sitting on this arm. I cannot find this arm rotation. I see this arm is at rest. Can I write? So this candidate, this one can write omega 1 by omega 2 as T2 by T1. This person can write, but you are not seeing gear 1 ka velocity and gear 2 ka velocity. Whatever you are seeing is relative velocity of gear 1 and relative velocity of the gear 2 with respect to your velocity. You are moving with omega of arm. So you are not seeing omega 1, you are seeing omega 1 with respect to arm. Omega 2 with respect to arm. You can write equation like this. External meshing hai, so you must use negative, or if it was internal, so you must use positive. So with plus minus, you can use this equation. How many of you can understand? I cannot write, but this guy can write the equation. This is the shortcut method, relative velocity method, and you are going to use this method to solve all the equations of gate. Objective equations, you can solve it using this method. No idea beta about the launching of batch D. No idea. And you can ask me this question in the Telegram group. I will confirm it and I will reply you in that group. And as of now, I have no idea. You are talking about Parakram batch D. And Telegram group mein, just connect with me. Ask this question there. I will reply you by tonight or tomorrow. ठीक है? Everybody is clear? How do we solve questions like this? Let me show you one question. This question have been asked in 2016 for 2 marks. 2 marks में they have asked this question. Question में क्या कह रहे हैं? In the gear train as shown, gear 3 is carried on arm 5. Gear 3 meshes on gear 2. This is my gear 2. 2 and 3 they are meshing externally, and this 3 is also engaging with gear number 4. Okay, internal meshing is there. The number of teeth on 2, 3, 4, gear 2, gear 3, gear 4, number of teeth they have mentioned 60, 20 and 100. Okay, if gear 2 is fixed, this gear 2 ko they have fixed, and gear 4 is rotating with angular velocity of 100 rpm in the counterclockwise direction, the angular speed of arm, tell me what is angular speed of the arm. How we can solve this question? Careful, careful, careful. Let me draw the diagram a little clear for you. We are having one gear. It is engaging with another gear. This gear 3 is carried on an arm. Arm looks like this. This is the arm. Okay? And then we have internal gear, which looks like this. This is your internal gear. This kind of situation they have given. Let me give it some name. They are calling it gear number 2. 2 is engaged with 3. 3 is engaged with 4. Arm ko they are calling as 5. So I am calling it as arm. Okay. This situation they have given. Careful. Acha, let me show you from this side how it will look. Sir, fixed link के साथ में we are having some shaft on which gear 2 is there. Careful. This is the shaft on which we are having a gear number 2. This is your gear number 2. 2 is engaging with 3. 2 is engaging with 3. How this is gear 3? Sir, gear 3 is this. This is your gear 3. And gear 3 ka whatever shaft we are having, this shaft is carried on arm. Arm looks like green color say. This is the arm. Arm is also rotating about the fixed link. Very, very careful. This arm is rotating about. This is the shaft of the arm. Something like this. And this 3 is messing with some internal gear. How that internal gear is looking? Sir, internal gear ka body is like this, having internal teeth. Sir, this is the internal teeth. This is the internal teeth. And let me show you the body. Body looks like this. This is the this is your white color ka internal gear. I have used the correct color coding so that you can get the feeling that how this system is going to work. Something like this. We are having this kind of situation, and we are having this is your fixed link. So fixed link के respect में arm is rotating. Fixed link के respect में your yellow color का gear is also rotating, and this internal teeth वाला gear is also rotating. Can you see? Gear 2 का rotation is independent. This is my gear number 2. Gear 2. 2 is meshing with 3. 3 is meshing with gear number 4 internally. Two is rotating independently. Arm is rotating independently. And this outer gear, which we call as ring gear, this is also rotating independently. Gear 2, gear 4, arm, they are coaxial. They are rotating on the different shafts. I hope which gear is engaging with another gear, how, which are coaxial, everything is cleared from this view, from this view. Now, can you write the equation, sir? Between gear 2 and gear 4, can we write the equation? Yes, we can write omega 2 by omega 4 with respect to arm. With respect to arm, can I write how from 2 to 3, 3 to 4 you are moving? Sir, 2 is driving 3. So T3 by T2. External engaging, external meshing, I will put a minus sign. Now 3 is rotating, 3 is driving 4. T4 by T3. Internal meshing, I will put a positive sign here. I think few things are getting cancelled. T3 gets cancelled. We are left with minus sign, plus sign. Minus plus is minus. We are left with minus ka T4 by T2 only. Can we put the values? Sir, omega 2, how much they have given? Gear 2 is fixed. So gear 2 is fixed. Ye fixed hai, so omega 2 is 0. Outer gear, gear 4 is rotating with, gear 4 rotates with angular velocity 100 rpm anti-clockwise. तो विद साइन आई हैव टू पुट द वैल्यूज. क्लॉकवाइज को आई एम सेइंग पॉजिटिव, एंटी क्लॉकवाइज को आई एम सेइंग एज नेगेटिव. So gear 4 का speed this is given as negative 100 anti-clockwise, so minus 100 I have put. Arm का speed I don't know, let me call this as x. X I have to calculate, है ना. Put the teeth how many they have given, 60, 20 and 100 teeth they have given. This is having 60, this is having 20 and this is having 100 teeth. So T4 by T2, T4 कितना है, this is 100 teeth and T2 is how much, 60 teeth. Put the values, solve it. 0 minus का x divided by minus 100 minus x is equal to minus 100 divided by 60. Can we solve this for the value of x? X कितना आ रहा है, anyone? With the sign positive or negative, can you tell me what is the value of x? Something RPM we are going to get. Try solving this and tell me answer beta. बताइए बताइए बताइए. Can you solve for this? What is the answer? कितना आ जाएगा? This negative gets cancelled. You will be having 60x will be equal to 100 plus x into minus 100. Let me take this minus 100 this side. It will be equal to 100 plus x. This is minus का 3 by 5 I think. Minus का 3 by 5x is equal to 100 plus x. Take this x this side, negative. तो minus का 3 by 5x minus x is equal to 100. कितना हो जाएगा? This is minus 8 by 5. X is equal to 100. X is coming out to be what? 500 divided by 8, negative. What is this value? 500 by 8 is how much? 500 by 8, 62.5. So this x is coming out to be minus का 62.5. अच्छा, what is the meaning of minus 62? Sir, minus 62.5 RPM. Minus is indicating that it is anti-clockwise. Anti-clockwise. Which option? 62.5 counterclockwise, 62.5 clockwise. Both options are there. Both options are present there. Which option I will select? I will select option C, anti-clockwise 62.5. Tell me in the chats, is everybody comfortable or not? Clear hai? So how questions are asked, how we can solve that? That's it. Examination mein, gear train mein, they are going to ask these many questions. Simple gear train, compound gear train, reverted gear train, epicyclic gear trains. They will ask questions on these. How do we solve this? Hai, we have seen the concepts, we have seen the each question, concept of question on the each concept I have shown you. Okay? So that's all for gear train. Tomorrow we will be meeting and we will be discussing about kinematic analysis, dynamic analysis of single starter crank mechanism. Sometimes they can ask question on that portion also. Sir, please explain the diagram drawn by you. Diagram में what you are asking, student का पूछना है sir, what is the meaning of external gear? First of all, external gear का मतलब होता है one gear is driving another gear like this. This is external meshing. I'm saying one gear is rotating about this fixed axis, another gear is rotating about another fixed axis. This is external meshing. I'm saying external meshing. Most of the time, whatever gears you have seen in your life, you have seen external meshing wale gears, है ना? If one gear is rotating clockwise direction में, the other gear will rotate in opposite direction. That's why I have written omega 1 by omega 2, T2 by T1 with a negative sign. But sometimes we have internal meshing also. Internal meshing का मतलब है one gear, it is rotating about some fixed axis, rotating clockwise direction में. It is engaging with some gear which is having internal teeth, and it is engaging like this. This gear is also rotating about its fixed axis. So one gear is moving clockwise, it is engaged with another gear, it will also be rotating clockwise direction. Both will be rotating in same direction. And here I have written, this is called as internal gearing. Omega 1 by omega 2 will be T2 by T1. This is my gear number 1, gear number 2, and both are rotating in the same direction. That's why I have put a positive sign here. Simple सी बात. This is what I mean. Clear है बात? So what is the meaning of external internal gearing? How does it affect the directions I have shown you? Teeth, if you will ask about the teeth, so sir, these gears will have teeth like this. We will be having teeth like this. We are having external teeth here. Here also you will be having external teeth like this. Like this. Both gears are having external teeth. On the other hand, if you are talking about this case, so one gear will be having external teeth. This gear, a smaller gear, is having external teeth. The other gear, it will be having teeth inward direction mein. It will be having teeth like this. It will be having teeth like this. Inward direction mein. So these teeth are going to engage with these teeth. How this situation looks, I hope this is clear. And you can see, you can Google it for some clear picture. I haven't taken those pictures. You can Google it. How internal gears, how external gears are going to engage. Now is this clear? The line diagram which I have shown. Okay. Just to give you the clear idea. Are bhai, if here you are asking how you have drawn, why haven't you asked it here? In compound gear, here also I have used the same kind of diagram. This is just another view. You are having shaft, shaft where we are having gear. Another shaft, we are having some gear. On this shaft, we are having another gear. So this similar diagram I have drawn here. क्या है? Sir, one gear, gear number 2 is rotating on some shaft. So I have made a shaft, and on this we have gear number 2. Gear 2 is rotating. It is engaging externally with gear 3. So this is gear 2 is rotating with gear 2 is connected with gear 3, and gear 3 का shaft is on some green color का arm. So this green color का body arm I have shown. Arm is rotating about this axis. This axis. And internal gear ko I have shown with this symbol. It is having teeth internally, and this is the body of the gear. Teeth are internal. Simple सी बात. It is also rotating on this shaft which is coaxial here. Simple. ठीक है? Nothing tough, nothing special. It was not needed for me to show you the side view. Side view I just have shown so that you can get a clear picture. Oh, arm is rotating independently, gear 2 is rotating independently, and gear 4 is rotating independently. They are just coaxial. They are on these different shafts. Okay. This is my Telegram group, Vishvajeet Sir PW. You can connect with me on this group. Tomorrow, I'll be discussing with you some new chapter, analysis of single slider crank mechanism. I'll be doing kinematic analysis as well as dynamic analysis. Examination में formula based questions are going to be asked. We will see some questions also. Very small chapter. Hardly it will take 1 hour or maybe less than that. So we will do some question practice also. Clear? Let's stop. Tomorrow sharp at 8. Tomorrow sharp at 7 p.m. 8 p.m. we are going to meet. Till that time, thank you, bacho. Goodbye. Love you all.